Hello, we are back again, and this time we are going to be talking about multiplying and dividing real numbers. All right, so let's take a look at a few tricks first that I wanted to share with you. In general, multiplying and dividing real numbers tends to be easier than adding and subtracting. And I think it's because really the same rules apply for both multiplication and division, and the rules are very, very simple. Basically, guys, if we are multiplying or dividing two numbers together, if they have the same signs, then they will have a positive answer. Here's a couple of examples. We have a negative 2 times a negative 5. Of course, a negative times a negative is a positive, so we'd have a positive 10 there. In the second example, we have a negative 8 divided by a negative 2, so it's division this time, but you notice that both of our signs are negative, so our answer is positive. The third example is just another way of showing the division. In fact, that's a lot more algebraic to show it with a fraction bar. And so a negative 48 divided by a negative 6 is going to give us a positive 8. So, this whole idea of paying attention to the signs is really important. It's also important to pay attention to how many of those signs we have. So I want you to notice in this example here, these are a little close together. This is actually supposed to be two different examples. I'll kind of just put a line there. So you notice we have 4 negatives, right? We have an even number of negatives. And because of that, we can always pair the two negatives up and create a positive, right? So if you have an even number of negative numbers, and that would include, of course, positive numbers, but we already know that an even number of positives is going to give us a positive anyway. We're kind of used to doing that. We don't really have to think about that. But with the negatives, we sometimes have to think through that a little bit. Here's another example over here. We've got negative 2 times negative 10 times negative 3 times negative 4. Once again, we have an even number of negatives, and therefore we are going to have a positive answer, right? And we can group these however we choose to. You can move them around using the commutative property, which we actually haven't really talked about yet, but we will be talking about that soon. But we know that a negative 2 times a negative 10 is going to give us a positive 20. And we can put together the negative 3 times the negative 4, call that a positive 12. And if we multiply those together, we could say 2 times 20, right? Or excuse me, let's do this. 10 times 20 is going to be 200. And then 2 times 20 is another 40. So that's going to give us 240. So we knew that those answers would be positive. All right, now let's take a look at the other option, which is negative signs. Different signs. What am I saying here? Different signs. So here we have different signs will always give us a negative answer. Positive 2 times a negative 5. Those are different signs, so that's going to give us a negative answer, negative 10. Here we have negative 8 divided by a positive 2. It's going to give us a negative 4. Positive 36 divided by a negative 6 is going to give us a negative 6. And here we have an example. I didn't leave myself a whole lot of room here, but you notice we have 5 numbers multiplied together. So the numbers don't necessarily matter, but if we look closer, we have 3 negatives. So we have an odd number of negatives in this particular case. And so we know that our sign is going to be negative, okay, because we can't pair up the negatives to create positives there. Okay, and of course we can, later on, we can, talk about moving these numbers around so that you can best multiply these without a calculator. But if we were to just go straight through, we're going to have a negative 8 here, right? And got a negative 5. Okay, times 10 times a negative 2. All right. We can call this a positive. We have a negative times a negative is a positive 40 times 10 times a negative 2. So we have one negative left. So now we have a 400 basically times a negative 2. So that's going to give us a negative 800. So we knew in the beginning we were going to get a negative answer because we had an odd number of negatives. Okay, and then you just do the math for the rest. Okay, so here's a couple of examples when we throw in fractions. Let's take a look at that. Here we have a negative fraction divided by a negative fraction, right? Negative, we have two negatives, so we know that we are going to have a positive answer, right? So we can look at that right at the beginning and just it's kind of a look ahead, and we know what to expect in terms of the sign of our final answer. Okay, in terms of the math, we have to remember division rules, and the division of fraction rules tell us to keep, change, and flip. So we're going to keep this first fraction, we're going to change this division to a multiplication, and we're going to flip this second fraction. I think I'm going to do this cross-canceling here because 5 goes into 10 two different times. And this would give me a negative 8 over a negative 3. We know a negative divided by a negative is a positive. So in this particular case, even though 3 does not go into 8 evenly in terms of simplification, we do need to simplify that because we know a negative divided by a negative is a positive. So this is the more simple way to write the answer. The other thing that you could have done, since you knew that the answer was positive anyway, you could have just dropped the negatives right from the beginning and just done your work with positive fractions. All right, let's take a look at this second example over here. Here's our second example. Okay, so we have two mixed numbers now that are being multiplied. We know that mixed numbers have to be converted to impropers when we're multiplying, and we ignore this negative right off the front, but we do see there's only one negative, so we know that our final answer is going to be a negative, isn't it? Okay, but we're going to ignore that negative when we're converting, so we say 4 times 2 plus 8, that's going to give us a 9 over 4, and we do know that we have that negative in front. We're going to tag that along. And here we would have 3 times 1 plus 1, so we would have 4/3. And these cross cancel very nicely. The 4s just totally cancel out, leaving a negative 9 over 3. And it's even more proper to bring that negative sign out front and just call it a negative fraction, which is a negative 9 over 3. Either one, though, would be completely acceptable. Okay, guys, so a couple of things I wanted to bring up. I want us to remember that we do not combine like terms when we're multiplying or dividing. We only combine like terms when we are adding or subtracting. When we're multiplying or dividing, we use exponent rules. And exponent rules will be talked about in great detail in Unit 11. Okay, so we are going to be really delving into these. So you may even want to watch the Unit 11 video on product and quotient rules first, okay, before you actually do some of this work. So a little hint of the using the product rule right here. We have a negative 3x times a 4x, and basically what we do, guys, is we multiply the coefficients together, right? So negative 3 times a 4, we have negative times a positive, that's going to give us this negative 12. And then we use the product rule, and the product rule tells us that we add exponents. Okay, if we have the same bases, we add the exponents. And you notice that both of these bases are x's. So we can add those exponents, and that's where we get this x squared, or x to the second power. So the whole thing is negative 12x squared. Quotient rule. Quotient rule tells us that we subtract our exponents when we have the same bases. Okay, we always, of course, look at our coefficients. We start there, and we have a negative divided by a negative. So negative 14 divided by negative 7 is going to give us 2. And you notice that our bases are the same. These are both x's. So this is actually going to be just x. We could pull this over here and say this is x to the 2 minus 2, which is x to the 0, which is x to the 1. This is also going to bring up another rule right here. Any number that's to a 0 power is always equal to 1. It's kind of a strange concept, but I love this example in that it shows why anything divided by itself is equal to 1. So x squared divided by x squared is just going to equal 1, isn't it? So those x squareds go out. They cancel out, leaving a 2. We'll definitely do a lot more examples of that sort of thing in Unit 11. Here's a couple other examples. So product rule, when multiplying the same basis, we add the exponents like we were saying. So let's look at this example here. We have x times xy times 2x times 3y. So the very first step that we're going to do is collect our same bases together. Okay, we're going to collect the same bases. So you notice I'm just taking everything that has an x in it, and I'm just collecting it all in one parenthesis. And then anything that has y's in it, I just go ahead and collect in another parenthesis. It's also really common, and I probably, had I redone this a different way, I probably would have also separated out my coefficients. I would have said 2 times 3, and then I would have separated those x's and separated those y's. Okay, that's actually showing in more detail what we're really doing. Okay, because we want to multiply those coefficients together. We multiply any of those coefficients and we bring them to the front. So you can see right here, this 2 times 3, I brought it to the front here in my answer. That's a 6. Okay, but paying attention to step number 2, we want to add the exponents when we have the same bases. So let's take a look here. We've got x's. I've got x to the 1 times x to the 1 times x to the 1, the first power. So we add those exponents, which is going to give me x cubed, or x to the 3rd, right here. Then we can look closely at the y's. We have y to the 1st power times y to the 1st power, which is y squared. Remembering that I brought that 3 out front already. Okay, so my final answer is 6x cubed y squared. All right, let's take a look at the quotient rule. And I'm just bringing these up, you guys, because you're going to need a little bit of this information when you're answering some of the questions here on the multiplication and division of real numbers. So that's why we're going over this now. All right, so the quotient rule, when we're dividing the same bases, we subtract. Whereas up here, when we're multiplying, of course, we add. And we have to remember that this is really talking about same bases. So it has to be both y's or both x's, you know, whatever that base is. Okay, so we're collecting the same bases down here. So number 1, we're collecting the same bases. You can see what I did is just bring the numbers out front, and that's just a fraction basically, right? 6 over 3, 6 divided by 3 is going to give me 2. I separate the x's out. I've got x squared over x, which if I use this quotient rule, so I'm reducing the fraction and then I subtract those exponents using the quotient rule, this is the same as x to the 2 minus 1, which is just x down here, right? I've got y over y. Well, we could have just gone like this. It's gone, isn't it? And we can see here, this is y to the 0, and we remember that anything to the 0 power is just 1. So that y just disappears. You notice it's not in the final answer at all. And then we will use the quotient rule on our z's. Z to the 3 minus 2 is going to give me z to the 1st power. You can see it here. And you notice when anything is to the 1st power, in our final answer, we just leave that 1 off of there as an exponent. We don't write ones usually as exponents or coefficients. It's more of an understood one. All right, so that's a little bit of a review on the product and quotient rule. Now let's just do a couple of problems that you guys will see on your worksheet and practice these ideas. All right, so I didn't number these problems. I just kind of took them from your worksheet. Here in the first one, we have a -5 times x times xy. Well, we can use this idea of collecting our same bases. Now, I will say, you guys, that if you don't need to do these steps, if you just kind of want to look at that and do, the product rule in your head, that's okay. For this particular thing, you do not need to go to lengths at writing out every single step. However, for some students, it's very important and very helpful to write out these steps. So I want you guys to figure out what works best for you. And, really, in terms of showing your work, if these problems become more and more complex, which they will, you do need to start showing me something, some of your process. But whatever that process is up to you, depending on how you're thinking through the problem. Okay? All right. So here all we have is one coefficient in terms of any number greater than 1. So we're going to bring that -5 down. We notice here we've got 2 x's. So we would just add these exponents together. It's going to become an x squared. And we only have one y. So we've got -5x squared y. All right, second example. So our second example can be done in several different ways. And it really is kind of just dependent on how you think about the problem. So I'll try to work it a couple of different ways. Let's isolate our coefficients so we can pull those out front. -8, we have a -2, and we have a 1/2. All right, so we could do that. We've got a -8 times a -2 times a 1/2. Okay, then I have 1x and I have 2 y's. Now this is the part that can be written lots of different ways. I want us to remember, you guys can see from up here that this 2 is kind of it is in the denominator. If we were to draw a line through up here, we could see that the 2 is in the denominator. So if you chose to, which I kind of like, because it shows, it really shows kind of what it means. We could just bring that 2 down here, because multiplying by 1/2 is the same as dividing by 2, right? We can also see that we have an even number of negatives, so this is going to be a positive answer, right? So -8 times -2 is 16, and 16 divided by 2 is 8. And we bring down the 1x that's sitting there, and of course we've got 2 y's. Those are the same bases, so we just add those exponents together. Okay, so however you see that, the coefficient part of that, you just kind of work it mathematically how you see that. All right, let's look at the third example here. Now this is an mn multiplied by a fraction, 1/mn squared. So this is kind of interesting. I think since that second factor is a fraction, let's make the first factor a fraction. Okay, so this is the same as mn over 1 times 1/mn squared. Now when you have two fractions multiplied together, we know that we can actually just set all of the numerators down, and I really like to do this, especially when we're dealing with variables. Okay, the ones I'm just leaving off because since we're multiplying them by other things, we can delete them. If a 1 was sitting there by itself, we need to keep it because we have to have that placeholder. But I really like this kind of this notation here, because it's very easy to see that these m's are going to cancel out with each other. And this n over n squared, we can actually show what that really means. It really means n over n times n. N squared just means n times n. All right, so we can see that one of these would go out, cancel out, leaving an n on the bottom, and of course we have to put a 1 on top because nothing is left on the top. So we have to have that placeholder. Okay, so our final answer would be 1 over n. Okay. All right, I suppose you could have looked at this also, just kind of do this one other way, mn over 1 over mn squared. You could have cross-canceled here too. You could have gone, okay, those m's are gone. This n is gone, leaving only 1, right? Which would easily show us what we have left as well. And that's the thing with a lot of these problems that have variables with them. You guys will see in a lot of the exponent problems that you're going to be working on in Unit 11, there are a lot of ways to go about simplifying those problems. And there's not one way that's more right than another way, as long as you're following the rules. It's really kind of how you think about it. And there are some, some problems where one technique will be faster than another or maybe more efficient than another. And we'll definitely talk about that in later videos. All right, let's take a look at this example down here to the left. We have some absolute value marks in this, and we need to treat those as if they were, we need to think about order of operations here. We also need to remind ourselves what absolute value means. Remember that absolute value is distance from 0. Okay, so once you get one number in an absolute value mark, you ask yourself, how far is that number from 0? Okay, well, we know distance can never be negative, so your answer is always going to be positive because we're not going to have a negative distance. We might have a negative number sitting in there, like the -2, but -2 is a positive 2 spaces away from 0. Now, another thing is when you have two numbers that are inside, or two or more, I should say, when you have some math inside the absolute value marks, you need to do the math first so that you come down to one number before you evaluate that absolute value. And we can see here that a -9 times a +5 is going to give us a -45. So now the absolute value marks in this problem only have one number inside, so we can evaluate it. Okay, well this is a negative sign, so we can just keep that, we bring that down, but the absolute value of -2 is 2. I'm going to bring down the multiplication sign. Absolute value of -45 is 45 over 3 times 7. Okay, and now we see we have this division here that we need to work on. We need to simplify that first. So 45 divided by 3 gives us 15. -2 times 15 times 7. If you look at this, we have one negative. So we know that our answer is going to be negative. It's going to give us a -30 times 7, which brings us to -210. All right, so the next example, you notice in the next example we don't have any multiple numbers inside an absolute value mark, so we can go ahead and evaluate the absolute value. Wow, that's a mouthful. Okay, absolute value of -4 is 4. Absolute value of -12 is 12. Times, we have the negative of an absolute value of 3 over an absolute value of 6, which is just 3 over 6. A little more work to do. I'm just going to bring this 4 down because I'm not using it yet. 12 divided by 3 is 4, right? And a -3/6 is the same as -1/2. So from here, there's lots and lots of ways that we can handle this problem. I guess I would probably choose to go ahead and multiply 4 times 4, which is 16. And from here, we could do a couple of different things. I'll show you a couple options. Right? This is just multiplied by a -1/2, which would be -16 over 2. Right? -16 over 2. Which is going to give you a -8. I'm going to go to the side just because I want to kind of show a couple of options here. You could have also just gone like that, boom, and taken those out, right? Of course, leaving the negative sign. Could have done that. What else? Okay, we could have gone 4 times 4, so this is up here. 4 times 4 times -1 all over 2. I think this is a little more complicated, but we could still do it. It doesn't really matter, guys, however you see it, as long as you're bringing the numbers and placing them where they need to be and following the rules, then you are good. All right, let's take a look at this last example. So we have a division of fractions with variables, and you notice we've got 2 negative signs. Got a negative right here and a negative right here. So we know that our answer is going to be positive. So you could just drop the negatives right from the beginning because we know that we're going to have a positive answer, or you can bring them along if that feels better to you. We also know that we need to follow division of fraction rules, which is keep, change, flip. So we're going to keep this fraction here, change division to multiplication, and we're going to flip the second fraction over. Now from here, there's a couple of different options. Okay, option 1 would be, for me, I like cross canceling, so I probably would have just canceled those out, leaving a -1 up here. And that would have given me 2 over 4y. And then I would have just simplified this fraction down. Excuse me, can't talk. 1 over 2y. Okay, I'm going to just erase this now. Just give myself a teeny bit more room. A second way of looking at that from up here, we could have said, all right, this is a -2 times a -x over x times 4y. This is a little bit longer, but you can see that we can start canceling everything out. You can even move things around. If you decided, okay, well, I don't like the x's not kind of in line with each other, you could have put the 4y over here, and you could have put your x over here so that we can see, oh, these cancel really nicely, leaving a -1. This cancels, leaving a -1. This cancels, leaving a 2. And in the end, we would have gotten the same answer. You can see up here that this version is easier, a little bit more straightforward, but once again, these are, the process that you guys use to simplify these is really up to you, as long as you're following the rules. All right, guys, that's it for now. We will talk to you soon.